Okie dokie, gonna aim for another 25-minute stream. I realised I didn't need to show you all the tests and things, so I've gone and done those. So we've got a helper function that's going to create a new test ink computer with a fixed set of instructions, and we've tested load mem and store mem, and it turns out there was a bug. And the test was failing, and it's that these two are the wrong way around. So in the previous one, those two are the wrong way around, and this is why we have tests. I've also added a test for instruction parsing, which is that this is going to give us a multiply instruction, and it should give us a multiply instruction with a value of 9, whatever is in memory location 10, and then we store it at the value of 3. So I've also created a parameters struct, which has inputs and a store location, and I've given that to add, multiply, and store. Load is just going to take a straight up usize, and terminate still takes nothing. So it's time to do parse next instruction. Let's get rid of that. Immediately we can start with, let be self load mem self dot instruction pointer, and load mem can return a result. Oh, sorry, load mem does return a result. Normally you want to do error handling when you have a result. One of the results could be an error. I assume this is just telling us that I'm returning the wrong type. Yeah, okay, fine. Load mem might return an error. If it returns an error, you can either handle it where you are, or if your function itself returns a result type, you can just say, well, exit early and pass my error up. And that means that instead of having to do the go thing of, var out is equal to sum func. You don't need the var if you're doing the colon, right? So it'll be sum func. And then you would do, are there semicolons in Go? I think there are. If error not equal nil, return error, right? All of this bit, and indeed capturing an output error, is what that question mark is doing. So in Rust it will be more like if instr dot is error, return instr, right? That is fine. I'm just going to return sure. No, because you can't have an instruction from string. Stupid. Let's just have terminate. Expected env found. Sorry, right, yeah. Better. So that that question mark will also unwrap it into the correct type, which in this case is refster, or a string slice, or a reference to a string slice. What it doesn't like is that, okay, so we are actually returning the wrong type here, because it kind of doesn't know this is definitely the error we want to return. You could match on this properly, but the point is we don't need to. Just need to do that. Cool. So instruction now is going to be, in our test case, it's 0 on 002, and it is a string. Well, it's a string slice. And the ways we could do about this is we could turn it into an iterator and reverse it. So we could do instr.iter rev take 2, and that's going to give us 2, 0. It's going to give us 2 and 0 as an iterator. I think. Yeah. Let's go take a look. I'm going to say Strua first, because it's possible I would need to have done chars instead of iter for this. I don't know if it implements iter straight away. Okay, so I'd actually need to go and do chars, which makes sense because it could be encoded in some weird way. But that... Are you now happy? Okay, now you're going to tell me what take does. So take is going to return an iterator with the first two elements, but we reversed it. So the first two elements are 2 and then 0. And that would give us our instruction, only it's going to give us our instruction the wrong way around. The other way to do it is, I don't know if you can, I think you can do this. Parse as a usize. And another question mark. Okay, yes. So the error that comes from parse is an error that they have defined because it comes up with a parseInt error. So really what you'd need to do, you can do this, but we'd need to go and make a type, or we'd need to go and basically tell it how to take a parseInt error and take it into just a string. And you can do that. There are other ways as well. You could do boxed in error, I believe. Yeah, I need another bracket. And the issue with this is now by doing boxed in error, that means that we're returning a thing which is the trait error, and the error trait basically gives you an error string. Both parseInt error and a string implement error, but we have no more information. We don't keep any of the information about the error we had before. Are there any fields we want? It's just you get the whatever error string you have. That's the cheating easy way to get around that, and sometimes that is the right thing, especially if you've got loads of types coming up. In this case, I'm just going to do that. Rustlings on errors does show the other side of how you get your errors to all map to, well, map, yeah, all map to the type you return, and also making your own error types. But I don't think that's important right now. So we passed it to an actual number. So now we have, what character did I just remove? Get away, please. So now we have the actual number 010 002. 010 02. Now it's worth noting that okay, here. So going right to left, the parameter modes are 0. In this case, they've left off the leading 0, right? They've got 0, so they've just got 1002. 0, that's this one, then 1, and then a 0 because it's not present. So that's now part of the spec and should go in the test, really. I might add that after the stream. And because this is a usize, actually we've got that because we've got a number. So we're sort of handling that implicitly, I guess, or it's going to be pretty explicit. Opcode is indeed going to be instruction mod 100. Divide by 100 mod 10, or just do mod 1000. I think you just do mod 1000, right? There's no reason to do this. Yes, there is a reason to do that. AI was correct. And that's because if I had 1002 and I just do mod 1000, I get 2. If I do 1002 divided by 100 mod 10, I get, well, the divide by 100 first will give me 10, because it's going to floor it. And then it will become 0, which is correct. Right, what we're looking for is that 0 there. And then if I did divide by 1000 mod 10, well, I end up with 1. 1 mod 10 is 1. So that's how we're going to do B and C. And this automatically deals with the fact that if it doesn't exist, then it's if it doesn't exist, then it's 0. Right, so that's that handled. That's quite nice. And now we need to match opcode. What have we got? So we'll start with a 1. And 1 is going to be add, I believe. 2 is going to be multiply. 3 is 3 store. Opcode 3 takes a single integer as input and saves it to the position given by its only parameter. Yep, and then 4 is load. And 99, of course, is terminate. Anything else? Invalid opcode, and we're just going to return an error type. Sweet. Right, terminate is easiest. That is just instruction terminate. And instruction terminate takes no parameters and is nice and empty. I can do this now. The output of this block, this is going to evaluate to something, and we can just return it. The output type is, so it's not that, it's an OK. Is it OK? Yeah, it's OK, instruction terminate. Great. So is a result type of either OK with an instruction or an error. Why are you specifically unhappy about 2? Oh, because there's a space there. Now, it's possible I might want a little helper function here, because otherwise this is going to get a bit big. But what we now know for add, we are going to have... previously I've said we could have many parameters. I think from this sort of spec, we can only ever have a maximum of 3 parameters. Right, because it's given us specifically A, B, C, D, E. So add will always add 2 numbers, multiply will always multiply 2 numbers, store will only ever store 1 number, and then load will only ever load a number. Which means that store has 2 parameters, load has 1, multiply and add have 3. 2 numbers you're adding and the place to store it. So now we need to go through A mode is this value here. So I'm going to write a little helper function on, yeah, fun get value. No, let's see what happens. There's probably going to be a bit of repetition here and I might spin this out. So let param A be equal to, ooh, I think this is a really nasty one-liner, right? It's going to be equal to if A mode is 0, then it is position, so we need to go load memory. self.load mem, and the address is going to be self.instruction pointer plus 1. And at some point we need to move the instruction pointer, and it might be worth doing that here. Is this a mute? This does not take mute self, so we can't actually do it. Mem. Par's next instruction needs to take a mutable reference to self, because it's going to be the easiest way to move the instruction pointer. And let's just do it here. Self.instru pointer plus equals 1. Let's unwrap that, or yeah, let's just unwrap it. Well, that should work in this block, yeah. Else, it's going to be literally the value at. Ooh. This is wrong. Why? Okay, so if it's 0, so let's say we've got whatever our test method, this one. So that is our vec. So currently our instruction pointer is going to be 1 because it's pointing to the number 9. 0 is position mode, so this needs to go and load. Is this really the... Going to need to go and load whatever's at position 9. I think my test is wrong. And yeah, that needs to be mutable because I've just changed my function definition. Fine. So I'm expecting this to have an actual value of 9 and a value of 30, but it's the wrong way around, right? It should be whatever's in position 9, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 99. That was a bad choice. And then the actual value here, which is 10. The store location, I think, is going to be whatever is in position 3. 1, 2, 3. So the store location should be 10. These are the absolute correct values. There's nothing will need to be done to go and change this. Let's just check that with the example. 1002. So I'm saying that we should get whatever's in position 4. Stored address 433. Yeah, okay. Sorry. So that test is now correct. And you really think I should have just used the example they gave me as a test. I might go and add that bit later. So it's either going to be the result of load mem I'm going to have to do 2 load mems, right? I don't have to do 2 load mems. Given I've written the function, it would be kind of dumb to now not use it. So it's a load mem on a load mem on the instruction pointer, right? So the first one, the inner one, is going to say load mem whatever's at position 2, and that's the value of 9. And then because it's a position parameter, we want to go and find out what's in memory position 9, so we load it again. Otherwise, we do load mem once on the instruction pointer. Okay, now it is... I don't want to return this. Ooh, that's disgusting. And then we do it all over again twice. For parameter B and parameter C. That's lots of red. And then we're going to return an instruction add with parameters, and the inputs are a vector of A and B, and the store location is parameter C as a usize and parsed. And that actually needs to be an OK. And we are straight up returning from this. Right, that's got rid of a lot of red. What don't you like? Yeah, that is right. I need to do this entire thing. Is that better? Don't like you. Incompatible types. Can I give that registrar to usize? I think maybe I need to put this in a function, or at the very least, not do these in one line. So we're going to load mem. Oh, the first time we do load mem, we get a ref stir back. Okay, this needs another function. And it needs to be in here because we want access to the memory. So function is parse param, and it's going to take a mutable reference to self, because it's also going to do because it's also going to just do the move the instruction pointer along. So we're going to take a mutable reference to self, and we're going to take the mode. Oh, bugger. Well, it's a good thing I've got it written down somewhere else. I probably shouldn't, because it was shit anyway. Mode is usize. Okay, and now let's do a straight up. I'll tell you what, we'll do a match block. No, match will require that I give it all the arms. So we'll just do if mode is 0, positional. Right. We are going to let param location be equal to self load mem. I need to move the instruction pointer along. Get rid of that line there. So self.load mem at self.instruction pointer. Which is a usize. And then as usize is another way we could convert this. No, okay. Parse as a usize. Failed to parse. Cool. Let param value then be equal to self load mem param location. And again, we're going to parse it now as an isize. Okay, so again, there are two possible errors we're returning here. Either the one we returned from load memory, which is just a string, or a parse error. And if I expect this, then I then need to go and wrap this in an OK, which kind of doesn't make any sense. I don't want to... I'll tell you what. We're just going to return an error. Fuck it. And that means I don't need to expect this. That is just the return value, right? Because I've got an extra bracket. Because we will either... So parse will return an error result. And the result will either be an isize or a parse in error, as it's showing there. Else... and we don't want param value. We just want to return that straight up. That's 25 minutes. This has not got very far. Maybe I am not the stunning coder that I thought I was. And actually, it's that line, isn't it? Except instead of param location, it's just instruction pointer. What don't you like about my boxed in? Oh, okay. I got rid of that import up here. Use standard error. That make you happier? Don't return an equals. And alright, fine. So I still need to do that. And presumably I still need to do it down here? No? Oh, I know I've been harping on about how errors in Rust are so nice and easy, and they're much better than in Go. And that is generally true, and it would be much better if I had used them in the past year, and not just been like, oh yeah, I will do this without thinking about it. So, operators and input types can't convert from iSize to result iSize. Yeah, so hang on, what was the original problem? The original problem is that it expects a boxed-in standard error, but it's getting a parse-in error. Let's just check. Maybe I'm just using the I think I'm just using the wrong error. No, I'm not. So the result type is boxed in error. That is correct. Yep. Can I be bothered to try and do this? I'm running out of time. For now, let's just fix this to return an error of string. We're going to expect that. I don't like this. I'm going to fix this outside the stream, and then I'm going to come back and I'm going to talk about how I fixed it and why Rust errors are in fact superior to Go errors. All you need to do is learn the language and wrap that in. And okay, are you happy now? Yes. Cool. And so actually this just becomes let param a equals self parse self parse param, thank you, with a mode. Let's get rid of those two. You are B mode, you are C mode, and it kind of annoys me that I've put the underscore letter on the other side of those, but I guess it makes it obvious. You get a question mark, and you get a question mark, and you get a question mark, and through the magic of Rust errors, everything sorts itself. And we'll do U as a U size. Expected, comma. I've got a bracket issue. Yeah, there we go. Okay, that's what it's going to look like for multiply as well. Let's just very quickly do that. We can do it. We can smash this out. There's not long to go. So you are store, and store is just going to have two parameters, which are the value to store and the place to store it at. Instruction store with parameters. Inputs are. Ooh, did I just give it one? What did I give it? It's a parameters type, so it's vec. Yeah, vec of param a, and store location is just perambulate. Thank you. And then for is just param a as a usize, and we're going to return an OK. Instruction load param a as a usize. Perfect. Does that pass the test? No. Why? So we got, again, I should have a consistent way of doing these. Left is the thing we actually got. So we got a 30 and a 10, store location 3, and what we expected was a 99 and 10, store location 10. So this is 100%, I think, what I was expecting to get the previous time, which means that it's just the logic is the wrong way around, right? If mode is 0, it is positional. So, I mean, like, if I do this, I think the tests will pass. But I don't think they should. No, the test didn't pass. Oopsie daisy. And that's because it returned an error somewhere. What are we up to? 32 minutes. Okay. I will investigate. Just flipping that logic shouldn't have made an error. I'm going to investigate. That's the stream where I've achieved nothing in 30 minutes, and I've misled you about errors. Next time, maybe I will magically, through the magic of not recording everything, have learned how to do errors.